So for this, everything we're about to do is going to be similar to what we did for compound inequalities. So that won't be that new. But if we have something like the absolute value of x greater than or equal to 5, we have to do kind of what we did for the equations, have a positive and negative version of this. So what we do is take whatever this is, whatever it says, x is greater than or equal to 5, that would be one of them. So that would be a closed circle at 5 on the right. But then we also take our negative 5, and because we've changed the sign of our number, we're going to change the direction of our sign as well. So x is now less than or equal to negative 5. So you have a closed circle going to the left. So if you start off with a greater than, this is going to be an or inequality. And then your interval notation would be from negative infinity to negative 5 with a bracket, or 5 to infinity. And then we can assume the opposite is also true, that if we start off with a less than, then we'll have an and, but we'll see how that goes. So this one, we would do the same exact thing. Our first one would be x is less than or equal to 8. If I switch that, that would be x is now greater than or equal to negative 8. And these are going to overlap. And because they overlap, we just want where they overlap, not both of these. So from negative 8 to 8, and everything in between. So if we start off with the less than, these are and inequalities. And our interval notation would be from negative 8 to 8. Now, let's say you don't remember is greater than or the and. That part doesn't really matter. You can solve it and then graph it and then figure that part out later. You don't have to remember that greater than is an or. It just might help you if you did. Do we have any questions on that part? The steps to solve an absolute value inequality are similar to the equation. Where you isolate the absolute value expression, create two cases, that's what we were doing. Keep one the same, and then switch the sign and the direction of the sign, which is what this method is. And then solve both inequalities, and then graph and write the interval notation. So we're going to do a few of these. Starting with number 3. So if your absolute value sign is already isolated, then we can go ahead and set this equal to this one and the negative version. This is going to be a greater than, so this is going to be a 4. And again, if you didn't remember that it was an or, you could just set up these two inequalities, figure it out, graph it, and then see if they graph apart or together. And then go back into the or if needed. Then we would solve these just like normal. So add 1 to both sides. So x is greater than 7, or x is less than -5. These would both be open circles, and that's nice with absolute value inequalities. They'll both be the same, either both closed or both open. So then our interval notation would be from -infinity to -5, or 7 to infinity. Do we have any questions on that one? And then we can do the same thing for number 4. Because this is a less than, we know this is going to be an and. So instead of making 2 separate things, I can write it as one condensed. So this would be -7 less than or equal to x plus 2 less than or equal to 7. And earlier we switched the sign, but if I look at this part, that's exactly what it is. We kept that part the same. This part, if we write it backwards, the sign would be changed. And we do have our negative. So the switch did happen. Then we could subtract everything by 2. To get our condensed inequality. So between -9 and 5 would be our graph. And our interval notation would be -9 to 5, both with brackets. So with these, you don't have to worry about like one being a parenthesis and the other being a bracket unless it goes to infinity or -infinity. They'll either both be parentheses or both be brackets. Do we have any questions on that? On the back, we're going to do 2 of these and then go back to doing final exam review. Now, if your absolute value inequality is not isolated, assuming this is going to stay at greater than may not be in your best interest. You may want to wait until it is isolated because the sign could change. In this case, it's not, but like number 8, it would. And then whatever you thought originally would be different. So for 9, we have to get rid of the -3 and the 10 on the outside. Get rid of the -3 first by adding it. And then get rid of the 10 by dividing it. Now that we have our absolute value inequality isolated, our sign is a greater than, so this is going to be in 4. So we can set it up as 2 different inequalities. X minus 4 is greater than 5, or x minus 4 is less than negative 1. And then solve both. Add 4 to both sides. So x is greater than 9, or x is less than negative 1. And these will be 2 open circles. From negative infinity to negative 1, or 9 to infinity. Questions on that one? For number 10, we can get rid of the 11 first. This will give us 4. And then get rid of the 1/2 by multiplying by the reciprocal. So multiply by 2 on both sides. Now that this is isolated, this is in fact a less than, so this is going to be an and. And I can write this as a condensed inequality with negative 8 and positive 8. Negative 8 is less than or equal to 4x minus 4, which is less than or equal to 8. And then I can start to solve. Add 4 to everything. Negative 4 is less than or equal to 4x, which is less than or equal to 12. And divide everything by 2. Negative 1 is less than or equal to x, which is less than or equal to 2. So these will be closed circles at negative 1 and 3. And then brackets, negative 1 and 2. The error is starting to work. Do we have any questions on that one? Mm-hmm. Or any questions on absolute value inequalities in general? So we're going to continue with our final exam review. Those of you not doing the final exam, if you want to keep working on this or do other things, that's fine. I believe we are almost done. We'll either finish today or tomorrow. We did 2.4 yesterday, we did not do 2.45, so that's where we're going to start. This is 8.5 on close to the end. I don't know what page that is exactly. I don't think they're numbered. For 245, we need to find our vertex. So we're looking at the number on the inside and the number on the outside. The number on the inside, we're going to take whatever that is and make the opposite. So this would be -1 instead of +1. And on the outside, we keep that the same. So our vertex would be the point -1, 3. From there, this is a quadratic. In normal quadratic, you go up 1 to the right one, up 1 to the left one. And this one doesn't have anything on the outside, so we're going to do the same thing. And then go out to the right 2, and up 4. And out to the left 2, and up 4. But after you get your vertex, if you want to check this in your calculator, you can do that also. So you could go into y equals and type this in. I have it, but it's not over here. And once I have this and my y equals go into my table, second graph, my vertex was -1, 3, so I'm going to start at that point and then go out from there as many points as I can. So -2, 4, -3, 7, -2, 4, -7, and then
do we have any questions on that? On the next page of this, there are 4 others. Are there any of those we would like to see or go over? Chris, do you need one of these? There's some on the shelf there. On the shelf. Yep, right there.
any on the back page you want to see or go over? If not, let's move on to 10.1. So this is what we were doing yesterday, solving absolute value equations. So we're just going to do a couple of these. For 254, we would need to get rid of the 8 before anything else. You can multiply both sides by 8.
Because we have a negative on this side, remember that absolute value equations cannot equal a negative, so there's nothing else we could do here. This would be no solution. For 255, I could get rid of 9. Don't let this confuse you. This is usually back here, so say plus 9, but now it's in front, we would still get rid of it first. And then divide both sides by 10. You have the absolute value of x minus 7 equals 4, which is a positive number, so we can then solve this. And we're going to set this equal to a positive and negative version of this. So negative 4 equals x minus 7, which equals 4. And then add 7 to both sides. So 3 equals x and 11. And then put that as a solution. Do we have any questions on that one? Are there any other questions in this section you want to see or go over? Last section. What we were just doing, our absolute value inequalities. So for 268, we would need to, this is already isolated. This is a greater than, so this is going to be an or inequality. So we're going to set this equal, or not equal to, but have two different inequalities. 10 plus k is greater than 7. Or 10 plus k is less than negative 7. And then solve both by subtracting 10 on both sides. We have k is greater than negative 3, or k is less than negative 17. Be careful when you're graphing, because these are counting by 2s. So the negative 17 we need to go in between. And so with the negative 3. In this case, we don't have to write this in interval notation. This is fine. So just leave it as inequality notation. Questions on that one? For 270, even though you know this is greater than or equal to, now we're going to isolate it, because that could change. We're going to get rid of 5 by subtracting it to the other side. So negative 7 times our absolute value of 5 minus 6k is greater than or equal to negative 49. Divide both sides by negative 7. We have our absolute value is now isolated. Our sign is going to change because we're dividing by a negative on both sides.
And now we have a positive 7. So now we can say this is a less than, so this would be an and. And then we could rewrite this as negative 7 is less than or equal to 5 minus 6k is less than or equal to 7. And solve for k. Subtract 5 on both sides, or on all sides, I should say. So negative 12 is less than or equal to negative 6k. It is less than or equal to 2. And then divide negative 6 again, or divide negative 6. And my signs are going to change again. I may have judged that picture that is greater than 1/3. Maybe 1/3 is going to be somewhere here. And 8 is less than 2. It's still 8. If you want to switch this around, you can. Do you have any questions on that? For our last one, if we start to solve this, we have to get rid of 7 first. So we could subtract 7 on both sides. And divide both sides by 5. Just like we can't solve absolute value equations that have a negative number, we can't do that with inequalities either. So if you end up with something like this where you have a negative, this would be no solution. We wouldn't keep going. Are there any others on this page we want to see or go over? So we have gone through the final exam review. The ones that we did not go through are on Canvas, so you can go back and double check those. Make sure you're working on that. Seniors, remember that your final is tomorrow. And then everyone else, your final is next Wednesday. So tomorrow and Thursday will be makeup days, retest days, for anything you still need to do. Remember that if you don't get your retake work done, the final exam will replace your marking period 4 stuff. So if you don't get your retest stuff done, don't feel like it's necessary. As long as you do well on the unit 8 and 9 stuff in the final, it'll still replace it. But you can still retest also. So with the remaining time left, I'm going to see if there's anyone who needs to finish the test, and if you are ready to finish that test, I'll pass it out.